In this video, I will show you how you can solve a one-sample t-test. A student in Corvallis has budgeted $33 for internet access per month. Will this be enough money to cover the service, or will it cost more? Suppose a random sample of 50 Corvallis residents who pay for internet access were surveyed. The average cost per month for internet access was $37, with a standard deviation of $9. Perform a hypothesis test with a significance level of 0.05. So the first step is for us to talk about really the question of interest here. The question of interest is whether or not it'll cost more than $33 per month for internet access. So if we write out our null and alternative hypotheses, we have our parameter is mu. This is the true population mean cost. This is going to be equal to $33 as our claim. The alternative will then be, is mu actually greater than this? Because what that means is that the student has not budgeted enough money. So now we should check our conditions. And the conditions for a one-sample t-test are whether or not we have a random sample, which we do. It says here that there's a random sample. So random sample, check. And also whether or not we have a large enough sample size, or we know that the population is normally distributed. Well, we have 50 Corvallis residents, so n is equal to 50, which is greater than 30, which is good to go. All right, so we've checked our conditions. Now we should calculate our t-test statistic. So t is going to be equal to x bar minus our claim divided by s over the square root of our sample size. In this case, our sample mean is 37. Our claim is 33. The sample standard deviation is here as 9. And the sample size was 50. This will be equal to 4 over the denominator or standard error of 1.27. giving us a t-test statistic of 3.14. Now, before we can find our p-value, we should also calculate the degrees of freedom, which are just simply n minus 1 for a one-sample t-test. So in this case, we have 50 minus 1, which is equal to then 49. So to find the p-value, we have to look it up on a t-table. So if we scroll down, we have a t-table here. Go to 49 degrees of freedom, and we have a test statistic of 3.14. We find that there is no 49 here for degrees of freedom. It just goes from 40 to 60. So that means that we should always round down. We have at least 40 degrees of freedom. So it's imperfect, but we'll go to the 40 degrees of freedom and scroll across the row until we find our test statistic of 3.14. And we find that this falls between 2.704 and 3.07, falls between these two values. So if we scroll back up, we can see that we did a one-tailed procedure, so our p-value is between these two values. So our p-value will fall between 0.005 and 0.001. So it's a really pretty small p-value, which means we should reject the null hypothesis. And also, it means that we have convincing evidence in favor of our alternative. So we have convincing evidence that the service will actually cost more than $33. So no, based upon this, there is convincing evidence that she has not budgeted enough money for internet access.